Let's start with parallel planes where we have to study about inconsistent system of equation, and then we can go to consistent system of equation. So we are going to start with parallel planes, type 1. Okay, type 1 is when all three planes are parallel to each other. So we have three planes which are parallel to each other. That's the idea here. Okay, how can we find whether they are parallel to each other or not? Good question. How do we prove that? Well, let's say we have pi 1 and pi 2 and pi 3. These are the three planes. Okay. So these three planes can have multiple normal vectors. Okay. Let's say pi 1 has n1 and pi 2 has n2 as a perpendicular vector. And let's say pi 3 has n3 as the perpendicular vector. Okay. So whatever the perpendicular vector is, okay, if they are parallel to each other, okay, if n1 is parallel to n2 and parallel to n3, we can say that pi 1 is parallel to, I can't underline that, pi 1 is parallel to pi 2 is parallel to pi 3. Okay, so this is the basic one you have to do when you're testing the interaction of three planes to come up with the final answer. So now you have to find out the normals first. Okay, so let's say n1 is equals to, let's say n1 is the perpendicular vector to or normal vector to pi 1. Well, then n1 will be equals to 5, 3, minus 7. Okay, n2 will be equals to 15, 9, negative 21. Okay, n3 will be equals to negative 10, negative 6, and 14. Okay, now we have to check whether they are parallel to each other. How do we normally check the parallelism of vectors? We just try to see whether they are multiples of scalar multiples of the other vector. So here we can see n1, if we multiply n1 by 3 times, we get n2. Okay, this implies n1 is parallel to n2. Okay, similarly, n3 can be given as minus 2 n1. Okay, it can be given as minus 2 n1. Why? To go from 5 to minus 10, you will multiply by minus 2. If you multiply by minus 2, the 3 by minus 2, you will get minus 6. If you multiply minus 7 by minus 2, you will get 14. So you can clearly see n3 is equal to minus 2 n1. Okay, n3 is equals to minus 2 n1. So this implies n1 is parallel to n3. Okay, so from these two relationship, we can say n1 is parallel to n2 is parallel to n3, which means pi 1 is parallel to pi 2 is parallel to pi 3. So what are the solutions for this specific scenario? Well, there are no solutions because they are parallel to each other. This is inconsistent equation. So these three system of equations or equations, Cartesian equations for plane, tell us that there is no real solution for these three planes. Okay, now let's talk about the second type. Okay, now let's talk about the second type. What is type 2? Well, I told you there can be two planes overlapping with each other. Okay, there can be two planes overlapping with each other. Okay, there can be two planes overlapping with each other, and the other plane can be parallel to them. Okay, and the other plane can be parallel to them. That's the idea. Okay, so let's say this is pi 1, and let's say this is pi 2, and let's say this is pi 3. Well, then you have to know if pi 1 and pi 2, the equations for pi 1 and pi 2 represent the same equation. Okay, if they represent the same equation and pi 3 is parallel to any one of these equations, it can be parallel to pi 1 or it can be parallel to pi 2. It doesn't matter. If it is parallel to any one of these, plane, well, then we can say the system of equations does not have a real solution. Okay, so how can we do this? Okay, so first of all, we know how to check for parallelism. Yeah, we know how to check for parallelism. What do? We have to check the normal vectors. So let's do a question first of all to understand how we can prove from parallelism to whether the planes are distinct or not. If they are distinct, that is type 1. If they are not distinct, they are type 2. Okay, so if they have given it like this, okay, if they have given it like this, first of all, what you have to do is, first of all, write the perpendicular vectors. So normal vectors. N1 will be equals to 1, comma 2, comma 3. N2 will be equals to minus 3, comma minus 6, comma minus 9. And N3 can be given as 5, comma 10, comma 15. And clearly we can see N1 is equals to, well, N3 is equals to 3N1, and N2 is equal to, sorry, not 3N1, 5N. I'm really sorry about that. 5N1, and N2 is equal to minus 3N1. This is obvious, right? You can clearly see that. So this implies N1 and N3 are parallel to each other. At the same time, N1 and N2 are parallel to each other, which means they are actually parallel to each other. So this implies phi 1 parallel to phi 2 is parallel to phi 3. This is proven by using this proof, okay, by using these specific data. Now what you have to do is, you have to check for the value, okay, you have to check for the value. That's all you have to do. Okay, so for pi 1, the d1 is equals to the d value. We normally say that a Cartesian equation of a plane is given as ax plus by plus cd, sorry, cz is equals to d. Yeah, this is what we normally do. So let's say pi 1 has the value d1 as 14, right? In this specific case, d1 is equals to 14, and d2 is equals to negative 52, and d3 is equals to 70. Okay, so here we came up with n3 is equals to 5n1. You check the same thing. d3 is given as 70. What about 5d1? Surprise, surprise. 5d1 is also 70. Okay, 5d1 is also 70. Okay, instead of giving this as minus 52, I'm gonna change it to, yeah, minus 52 is fine. Yeah, minus 52 is fine, perfectly fine. Yeah, so minus 52 is fine. Okay, so 5d1 is equals to 70. This implies, okay, n3 is equals to 5n1, d3 is equals to 5d1. This means d3 is equals to 5d1, which means phi 1 and phi 3 are the same equation. They are the same plane. Okay, this implies phi 1 and phi 3 are same equations, are same plane, or you can say they are overlapping. Okay, now let's check for pi 1 and pi 2. Okay, let's check for pi 1 and pi 2. Well, n2 is equals to minus 3 n1. Okay, so let's check minus n2 is given, sorry, d2 is given as negative 52, and 3d1 is equals to 14 times 3, 42. So negative 3d1 is equals to negative 42. So this means they are not equal. Okay, so pi 2 is not the same plane as pi 1. Therefore, pi 1 and pi 3 are overlapping with each other, while pi 2 is a distinct plane. This is the second type. Okay, you just have to check for the d also. Not, you can't stop with n1, n2, and n3. Not n1, n2, and n3. Sorry, n1, n2, and n3. You have to also check d1, d2, and d3. Okay, so if two planes are overlapping and one plane is distinct and parallel to the other two planes, well, then we can say they don't have solutions. They do not have solutions. Okay, why? They are not intersecting with each other. Yeah, so this is the type 2 of inconsistent, yeah, inconsistent interaction or inconsistent system of equations.
Thanks for watching the 40-second video in our Vector series. If you found this exploration of parallel and distinct planes helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master vectors, and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.